In this video, I will be explaining how to balance chemical equations. So, for this first example, we have methane plus oxygen turning into CO2 and water. So, to start doing this, we need to set up a table. So we write the elements that are on this side of the chemical equation over here, the reactants. So C, H, and O. And we'll write the products, the elements that are in the products. So C, H, and O again. So in all these chemical equation balancing problems, we want to, well, essentially have the same number of atoms on the products and on the reactants and the products. So on the reactant side, we have one atom of carbon. We have 4 hydrogen atoms. We have 2 oxygen atoms. On the products, we have 1 carbon, 2 hydrogen, and 3 oxygen. So the first thing that we want to do is balance the hydrogens, because as you can see here, we have 2 hydrogens on the products and we have 4 on the reactants, so those are not balanced. They need to be the same. So what we want to do is multiply this water by a factor of 2. So we put a 2 in front of the H2O. And what that does is it multiplies each element by that number. So we have 2 in the products for hydrogen, so we multiply by 2. So that gives us 4 hydrogen on the product side. So a 2 times 2 here, it's 4 hydrogens on the products. And it also multiplies the oxygen. So 2 times 1 oxygen is just 2. So 2 plus 2 is 4. So we can write 3 plus 1 is equal to 4. So we have 4 oxygens on the product side. So what we can see now is that we have everything balanced except the oxygen, because we have 2 over here and we have 4 over here. So we want to balance the oxygens on the reactant side right here. So all we have to do is we have to put a coefficient of 2 here, and that 2 multiplies this 2, and that gives us 4 oxygen atoms. And this equation is balanced. Okay, let's do another problem. So this time we have water decomposing into H2 and O2. So we do the same thing as the last problem, we make a table. So this time we have hydrogen and we have oxygen on the reactant side and the product side. So this is for the reactants and this is for the products. So now we can count. So in the reactants we have 2 hydrogens and we have 1 oxygen atom. In the products we have 2 hydrogen atoms and we have 2 oxygen atoms. So what we want to do is we want to balance the oxygen because everything else is balanced. So we multiply the oxygen, we multiply the water here by a factor of 2. So that'll multiply the hydrogen by 2, and it'll multiply the oxygen by 2. So now the oxygens will be balanced, 2 oxygens on the reactant and 2 oxygen on the product, but the hydrogens aren't balanced. So we have to multiply the hydrogens on the product side by a factor of 2. So we put a 2 here to multiply and give us 4 hydrogen atoms. So now this chemical equation is balanced. Okay, let's do another example. So this next example is a little bit more challenging than the ones that I've done so far because it involves more elements. So we have C2H6 plus O2 turning into H2O and CO2. So this is a combustion reaction, and these are usually the most difficult type of equations to balance. So what we want to do first is set up the table. So we have carbon, hydrogen, oxygen on both sides of the equation. Carbon, hydrogen, and oxygen. So let's count. So we have 2 carbons here. We have 6 hydrogens there, and we have 2 oxygens there. So that's for the reactants. So for the products, we have 1 atom of carbon, 2 atoms of hydrogen, and 3 atoms of oxygen. So what we can start by doing is we can start by balancing the carbons. So we have 1 here and 2 here. We can multiply this CO2 by a factor of 2 so that the carbons will balance. So we'll have 2 carbons on the product, 2 carbons on the reactant. But this will also multiply the oxygen. So we have 2 here, 2 times 2 is 4. 4 plus this oxygen is 5. So we can say 3 plus 2, we have 5 oxygen atoms on the product side right now. So now we can do is we can balance the hydrogens. So we have 2 here, 6 here. What we can do is multiply this water by a factor of 3. So 3 times 2 will give 6 hydrogens, so those will be balanced. But it will multiply this oxygen as well. 3 times 1 atom of oxygen is 3. 3 plus this 4 atoms of oxygen will give 7. So we can say 5 plus 2 equals 7. So in total we have 7 atoms of oxygen on the product side right now. So everything is balanced now except the oxygen. The problem now is that we can't multiply any whole number by 2 to give 7 to balance the oxygen. But what we can do is we can multiply it by 3.5, or otherwise 7 over 2. Because 7 over 2 is the same as 3.5. And 3.5 times 2 gives 7. So let's write that as a fraction. So 7 over 2. But the problem is with this is we can't have fractions in a chemical equation. So what we can do though is we can multiply this whole thing by 2 to cancel out this 2 down here. Because if we multiply this 7 by 2, we can cancel out this 2 down here. So once we multiply everything here together, the chemical equation will look like this. It'll look like 2C2 H6 because we multiply by 2, plus this will multiply the O2, and we'll have 7O2 because the 2's will cancel, and this will turn into 6H2O because we're multiplying the 3 by 2, and we'll have 4CO2. So this will be the balanced chemical equation. And if you want to, you could set up a table and you could count all the elements and they would all be equal. So for combustion type reactions, sometimes you have to write a fraction in order to balance the chemical equation. Okay, let's do one last example. So we'll do another combustion reaction because those are tough to do. So this time we have C8H18 plus O2 will turn into CO2 plus H2O. So let's make a table again. C H no C H and O. So we have 8 carbon atoms in the reactants, 18 hydrogen, and 2 oxygen. We have 1 carbon in the product, 2 hydrogen, and 3 oxygen. So we can start by balancing the carbon. So we have 1 here and 8 over here. We want to multiply this carbon by 8. So that means we have to multiply this CO2 by 8. So that'll multiply the carbon by 8, and it'll multiply the oxygen by 8. So 8 times 2 is 16. 16 plus 1 oxygen over here, that's 17. So we can say that plus 14, so that it will equal 17. So we have 17 oxygen on the products right now. So now what we can do is we can balance the H2O, or the hydrogen I should say. So we have 2 over here, 18 over here. We multiply this one by 9, and this will give us 18 hydrogen atoms on the product side. So we put a 9 in front of this. 9 times 2 gives 18. 9 times the oxygen, 9 times 1 is 9. 9 plus 16 oxygens over here will give 25 oxygen in total. So 25 oxygen in total on the product side. So now everything is balanced except the oxygen. And again, we have to use fractions to solve this. So we can multiply it by 25 over 2, and that'll cancel, and we'll have 25 oxygen atoms on the reactant side. So we'll have the same amount of oxygen. But we can't leave it like this, so we have to multiply the whole thing by 2 to get rid of this fraction. So when we multiply everything by 2, we will get 2C8H18 plus 25O2 turn into 16 CO2 plus 18 H2O. And that is the balanced chemical equation.